let's find the center of mass of this uniform plate of inner radius r1 and outer radius r2. Okay, so what we can do here is that we can think of this semicircular plate as made up of many semicircular rings. Okay, so if you know, for a semicircular ring of radius r, the center of mass lies at 2r by pi distance from the origin. Okay, so at certain height 2r by pi, correct? We have to find out the center of mass of this body. So how will we do that? We will consider that this entire semicircular disc is made up of many semicircular wires. Okay, right. So now what we can do here, we can assume a semicircular ring over here like this of certain radius small r. Okay, certain radius small r. So I will show you the radius. Let's say the radius is small r, correct? And I will assume that it has a very small thickness. Okay, this semicircular ring has a very small thickness. Let's call that as dr. Okay, not thickness, actually you can say the width. Okay, width of this strip is dr, correct? Okay, now this particular semicircular disc as a whole has a uniform mass distribution, right? So you have sigma, that is mass per unit area. So if I assume the mass is capital M, then divided by the area. So what is the area of this disc, the whole disc? It is pi r2 square minus pi r1 square. But this is the area of a complete circle, but this is a semicircle, right? So we will divide by 2, pi r2 square minus pi r1 square by 2. Okay, so this sigma will become 2m upon pi times r2 square minus r1 square, right? Okay, so this is the value of sigma. Now for this semicircular ring of radius small r, we have a certain area and certain mass, right? So the mass of this is dm. The mass of this disc is dm. Now this semicircular ring has the center of mass at a distance 2r by pi, right? 2r by pi. Now there will be many rings which will have this particular center of mass of different radii. Okay, so now we have to take this as our coordinate of the center of mass and use this formula ycom is equal to integral rdm, or you can say ydm for this. Okay, not rdm but ydm divided by capital M, right? So this is the formula. So now for this dr, the ring with the thickness or the width dr, this center of mass is 2r by pi. So this is 2r by pi divided by capital M. Okay, so let me complete this ring like this. Okay, so now the integration is over the total mass, but now dm and r, see r is a variable and dm is also a variable, right? So I will write dm in terms of dr, right? So how to do that? You know the area of this particular ring, right? It will be pi into small r. The area of this small ring is dA, which is pi into small r, into the thickness, which is dr, right? So instead of dA, we can write pi r dr. But now dm, how will you write dm? You know sigma is dm by dA, right? So dm can be written as sigma times dA. Dm can be written as sigma times dA. So this is integral 2r by pi. This is sigma times dA divided by capital M. So this will be equal to sigma 2 by pi m integral r times dA. But dA is pi r dr, right? So this will be pi r dr. Okay, now this will be from r1 to r2. The integration will be from r1 to r2. The first ring will start from the r1 radius and the last will be at r2. Okay, so let's integrate this. We will get 2 sigma upon pi m. This is pi is taken out and integral r square dr. This is from r1 to r2. So this will be this pi and pi gets cancelled. This is 2 sigma by m. this is r cube by 3, and this is r2, and this is r1. r2 is the final limit and r1 is the initial limit. This is 2 sigma by 3m. This is r2 cube minus r1 cube, right? So this is your YCOM, okay? YCOM, the position coordinate of the center of mass. But what is sigma? We know that sigma is 2m upon pi r2 square minus r1 square. So I will write it over here. YCOM is equal to 2 times sigma. Sigma is 2m by pi. 2m by pi r2 square minus r1 square into 2 sigma by 3m into r2 cube minus r1 cube, right? So this m and this m gets cancelled. Sorry, this is sigma. So we actually substituted for sigma, right? Why I am writing this? Okay, this is 2 sigma. Sigma value is this, okay, by 3m. Yeah, there is no need of this 2, right? 2 sigma. This is sigma already by 3m. There is no need of that 2. So this is 1 only. Okay. So this will be 4 upon 3 pi. Now this is r2 cube minus r1 cube divided by r2 square minus r1 square, right? So now we can write this as 4 upon 3 pi r2 minus r1 into r2 square plus r1 r2 plus r1 whole square divided by r2 square minus r1 square can be written as r2 minus r1 into r2 plus r1, right? So these two things will get cancelled out and you will get 4 upon 3 pi r2 square plus r1 r2 plus r1 square divided by r1 plus r2, right? So this is what you get as a center of mass y coordinate. Okay, so this is the answer for that.